So we are at the final part of chemistry chapter 3, acid, bases and salts. This part is about water of crystallization, efflorescence and deliquescence. First, let's understand what is water of crystallization. This is the, you can say, proper definition of water of crystallization. Please note it. Some salts, while crystallizing out from their solutions, unite with a definite quantity of water, which is known as the water of crystallization. We saw that in preparation of salts, preparation of soluble salts, that when the supersaturated solution of salts was cooled, when the saturated solution of salts was cooled, salt crystals, they separated out. Okay, how did salt crystallize? How did salt from the soluble form get converted into crystal form or crystalline form? So these salt particles, they unite with a definite quantity of water, and this water is known as water of crystallization. This water of crystallization is in loose chemical combination with the salts, and it can be driven out by heating the powdered crystals of these salts above 100 degrees Celsius. Okay, so as you can see over here, copper sulfate CuSO4 dot 5H2O. This dot 5H2O means water of crystallization. If you heat this hydrated salt means the salt which contains water of crystallization, the salt which is in crystalline form. If you heat this hydrated salt, it will give you anhydrous copper sulfate, which is white colored powder, plus water of crystallization molecules which are driven out of this crystalline salt. Acha, if you combine white amorphous anhydrous copper sulfate with some water, it will again recombine to form hydrated blue crystals of copper sulfate. Okay, so this has been shown here with the experiment, that first copper sulfate crystals are taken in a test tube, they are heated, drops of water are collected at the mouth of the test tube, which are driven out of the hydrated copper sulfate by heating them. When these hydrated copper sulfates are again, you can say, added or mixed with water, when the dehydrated particles of copper sulfate are again mixed with water, they again become hydrated. They regain their blue color, they regain their crystalline shape, right? So that is all due to water of crystallization. Now understand what are the implications, or you can say what are the characteristics of the presence of water of crystallization in any salt molecule. Okay, so water of crystallization, it gives two things. It gives two things to a salt. It gives a peculiar color. It gives color to the salt, with which you can identify this salt is made up of which metallic ions. So that's a peculiar color. And it gives its crystalline shape. Water of crystallization gives the crystalline shape to salt. It gives color to salt. In the absence of water of crystallization, the salt becomes anhydrous or amorphous. Amorphous or anhydrous simply means that it has lost its color as well as shape. It has lost its color as well as shape. The crystalline shape and the color both are lost. It becomes white powder. Anhydrous or amorphous forms is simply white powder of that salt. Okay, so water of crystallization, it actually helps us to identify that this salt is made from which metallic ions are present in this particular salt. Okay, now see, water of crystallization has been collected here in the form of drops. If you add these drops back to you can say any amorphous or dehydrated salt, they will again make this salt hydrated. They will make this salt regain their crystalline shape and their peculiar color. So it shows that the liquid is water. Some common salts containing water of crystallization: washing soda crystals. Washing soda crystals means sodium carbonate decahydrate, Na2CO3.10H2. Epsom salt, magnesium sulfate heptahydrate, MgSO4.7H2O. Potash alum, hydrated potassium aluminium sulfate, K2SO4.Al2SO4 thrice.24H2O. It's a mixed salt. Glauber salt, sodium sulfate decahydrate, Na2SO4.10H2O. Blue vitriol, copper 2 sulfate pentahydrate, CuSO4.5H2O. Plaster of Paris, calcium sulfate semihydrate, or sometimes it is known as hemihydrate, CaSO4.5H2O. White vitriol, zinc sulfate heptahydrate, ZnSO4.7H2O. Gypsum, hydrated calcium sulfate, or CaSO4.2H2O. These are all salts containing water of crystallization which are commonly used by us. Okay, so uh, there are other salts also which do not contain any water of crystallization but are in crystalline form. For example, common salt, NaCl. Now, common salt, if you have seen rock salt, it is crystalline in shape. Rock salt is crystalline in shape. Okay, but uh, it does not have any water of crystallization. So, just by looking at the shape, you can't say whether the salt will have water of crystallization or not. Niter or potassium nitrate, it's a crystalline solid but does not have water of crystallization. Sugar, potassium permanganate, ammonium chloride, these are all crystalline salt but do not contain water of crystallization. If you want to make sure that whether these salts really have water of crystallization or not, you can do one experiment. You can heat a few crystals of pure sodium chloride or potassium nitrate separately in different test tubes. On heating, crystals of sodium chloride produce a crackling sound, and this crackling sound, or the process of breaking up of sodium chloride crystals, is known as decrepitation. This is due to the bigger crystals breaking up into the smaller ones. What happens with potassium nitrate? The crystals of potassium nitrate melt into a colorless liquid and on further heating produce oxygen which rekindles glowing splinter. Potassium nitrite, a pale yellow solid residue, is left behind. So on heating potassium nitrate, you don't find water of crystallization. You find potassium nitrite, which is a yellow residue, plus oxygen is liberated. So these crystalline salts, yet they are crystalline, but still they do not have water of crystallization, and they do not produce water vapor on heating. So all crystalline salts do not contain water of crystallization, only some do. Okay, first term, important term. Please remember the definition. This term is known as efflorescence. What is efflorescence? Efflorescence is the property of some substances to lose wholly or partly their water of crystallization when their crystals are exposed to dry air even for a short time. So these substances, these salts, they contain water of crystallization, and when you expose it to atmosphere, they lose this water of crystallization wholly or partly, and they become dry. They become powdery, right? And they lose their color. Such substances are known as efflorescent substances. Efflorescent substances lose their water of crystallization, and thus their crystalline shape becomes powdery when exposed to air. Examples are washing soda, sodium carbonate, hydrated sodium carbonate. It becomes dehydrated on exposing to dry air. Glauber salt, sodium sulfate becomes powdery anhydrous sodium sulfate when exposed to air. Epsom salt, magnesium sulfate heptahydrate, when exposed to dry air becomes monohydrate, almost powdery. The higher the temperature of the air, the higher the efflorescence. This is because air absorbs more water with rising temperature and decreasing moisture or humidity. Then the second term which we have to study regarding the uh, crystalline salts is hygroscopic substances. Certain substances, mostly salts, absorb moisture or water vapor from the atmosphere without dissolving in it. Such substances are called hygroscopic substances, and the phenomena is known as hygroscopy. So what are these substances? Concentrated sulfuric acid, phosphorus pentoxide, quicklime, calcium oxide, silica gel. Have you seen silica gel packets? Small silica gel packets are placed in water bottles which you buy from the market, basically new packed water bottles, shoe boxes or shoes, sports shoes basically. Uh, you can say school bags, or any general bags. You will find small packets of silica gel. This silica gel is a hygroscopic substance. So what is the function of silica gel? Silica gel absorbs the water or moisture which is present inside any closed, you can say, area. So, moisture, when accumulated in a closed area, it gives rise to bacteria. And these bacteria or microorganisms, they try to attack some, material. They can, there can be fungus or algae, and these kind of substances, uh, they completely destroy some surfaces. Okay, the surfaces becomes contaminated, you can say, with the deposition of these kind of microorganisms. And these microorganisms, they reproduce very fast, regenerate very fast in moist conditions. So we have to keep these areas, these closed areas, dry. So how to keep them dry? You can put a packet of silica gel. Silica gel will absorb the excess moisture present in these closed areas. So your wallet, your purse, your bag, your school bag, your water bottle, your shoe box, your shoes, they all, when they are new, they are packed with silica gel packets. And when you before you use them, you should throw out the silica gel, because that was just kept there to keep these areas dry. Now, there is always this caution which is written on the packet of silica gel: do not consume. Yeah, because that is not a consumption based item. Okay, that is just to keep that area dry. If you consume, it can be poisonous and it can react with your body and you may die. So don't do that. Okay, so silica gel packets, you can also buy them, silica gel packets, or you can say, collect these packets and keep them in your shoe rack or your shoe box, wherever these closed spaces where moisture can accumulate and can create, or can give a suitable environment for fungus to grow. So for in rainy season, mostly this is the problem. Shoes become infested with this fungus and everything. So in order to keep your shoes and your belongings safe and dry, you should always keep these kind of hygroscopic substances around. Calcium oxide, quicklime, is also a hygroscopic substance which is used in many experiments. And the best, you can say, dehydrating or hygroscopic substance is concentrated sulfuric acid. In the previous section, we did one experiment, that is formation of iron chloride. And in the formation of iron chloride, this chlorine gas was passed through concentrated sulfuric acid to remove all the moisture from it. Because concentrated sulfuric acid is a hygroscopic, or you can say, dehydrating agent, so it removes moisture from chlorine gas, and then chlorine gas without moisture can combine with heated iron, to produce iron chloride. So in many chemistry experiments, these hygroscopic substances have their use. Okay, let's go to the next kind of substances. Here they have mentioned in laboratory, these substances are used generally for drying gases for removal of moisture from gases. That way I just gave you an example. Next term is deliquescent substances. What are deliquescent substances? Certain water soluble substances, when exposed to atmosphere at ordinary temperature, they absorb moisture from the atmospheric air to become moist and ultimately dissolve in the absorbed water, forming a saturated solution. Such a substance is called deliquescent substance, and the phenomena is known as deliquescence. Okay, so I will give you some examples. Caustic soda, sodium hydroxide; caustic potash, potassium hydroxide; magnesium chloride, MgCl2; zinc chloride, calcium chloride, ferric chloride, zinc nitrate, copper nitrate. You must take care that all these substances must be kept dry, must be kept dry. Why? Why do we have to take care about keeping them dry? Because if they are exposed to atmosphere, they will absorb moisture from the atmosphere and ultimately dissolve in that absorbed water and become saturated solution. They become watery. Okay, deliquescence occurs when the vapor pressure of salt is much lower as compared to atmospheric vapor pressure. So deliquescence is minimized during dry conditions, whereas efflorescence is maximized in dry conditions. Efflorescent substances loses their weight while hygroscopic and deliquescent substances gain their weight. Now, what is the difference between hygroscopic and deliquescent substances? They both absorb moisture from atmosphere, but hygroscopic substances, they do not dissolve in that moisture. They remain dry even after absorbing the moisture. But deliquescent substances, they dissolve in that absorbed moisture and become saturated solution. If you want to do an experiment, you can do it with a table salt, that is sodium chloride. What does it do? It turns moist and ultimately forms a solution on exposure to air, especially during rainy season. So this is a very good season for experimenting with uh, sodium chloride and prove it that it has got some deliquescent substances in it. See, sodium chloride is not part of this deliquescent substance list which we just saw here. Then why do sodium chloride uh, becomes moist or behaves like a deliquescent substance? Because it contains some impurities like magnesium chloride. These are not like harmful impurities, but they are naturally occurring impurities in sodium chloride, your common salt which is found in market. So it has got impurities like magnesium chloride and calcium chloride, which are deliquescent substances. Okay, so what is the experiment? How you can prove that table salt is deliquescent or it contains deliquescent substances? You can take some table salt in a dish and you can put it near your window, where the, of course, in rainy season it works the best. And put it near the window. Make sure that rain does not directly fall into it. Okay, so put it near window, not in the rain, not outside, and observe it after a couple of days. You will observe that not even a couple of days, maybe if it is raining, or if it is too moist or too humid outside, it will happen in, you can say, half a day, few hours maybe. This salt will become moist, very moist, and it will ultimately show some liquid around it. So that's a saturated solution of salt. You might have also observed that your salt dispenser, which we keep in on our dining tables basically, and on in many restaurants you will find salt dispensers, which is used for, adding salt in your food while you're eating. So these salt dispensers, they have holes in them, and when you try to put salt, sometimes when you try to take out salt from the salt dispensers, you observe that the salt has stuck. It has stuck to all the, you can say, walls of this salt dispenser bottle. Why does this happen? Because the salt has become moist, because it's a deliquescent substance. So these kind of impurities can be removed by passing a current of dry hydrogen chloride gas through a saturated solution of affected salt. Pure sodium chloride is produced as a precipitate, which can be removed by filtering and washing, first with little water and finally with alcohol. Not a home remedy. This is the remedy for chemical lab. Okay, so don't try it at home. You cannot try that at home. Okay, the final term is drying and dehydrating agent, or drying or desiccating agents. What are these? Certain substances remove moisture from other substances and are therefore called desiccants or desiccating agents or drying agents. Almost all hygroscopic substances are desiccating agents. So this is, you can say, studying hygroscopic substances in depth. For example, concentrated sulfuric acid, phosphorus pentoxide, silica gel, and quicklime, all hygroscopic substances. So what do? Dehydrating substances, agents, are those substances that can remove water molecules even from compounds. Concentrated sulfuric acid can remove water molecules from blue vitriol, hydrated copper sulfate. So it is a dehydrating agent as well. Okay, they can remove chemically combined water from any compound. So they are very strong drying or dehydrating agents. So all you can say hygroscopic substances, they have certain property, but uh, concentrated sulfuric acid has this property uh, at the maximum. Okay, so here there is one difference given between drying and dehydrating agent. Okay, drying agent, they remove moisture from other substances, but dehydrating agent, they remove chemically combined elements of water in the ratio of 2 is to 1 from a compound. The drying agent are used to dry gases like chlorine, sulfur dioxide, hydrogen chloride, etc. They are also used in desiccators to keep substances dry. But dehydrating agents, they prepare substances like carbon monoxide, sugar, charcoal, etc. Drying agents represent physical change, dehydrating agents represent chemical change. Drying agents are phosphorus pentoxide, calcium chloride, calcium oxide, concentrated sulfuric acid, but in dehydrating agent, we just have concentrated sulfuric acid. Right, so we have a final in-text question exercise and miscellaneous exercise based on ICSE examinations, which has got many important questions. In order to understand this, your idea regarding this chapter, you must solve these exercises so that we know that we have understood this huge chapter very well. Okay, so we have completed the third chapter. Now in the next video, I'm going to make I'm going to cover the fourth chapter, that is analytical chemistry. Not in this video, maybe in the next video very soon, which will be out. I'll be covering the next chapter of you can say chemistry, and then we'll move to physics. Okay, so that's the plan. I'll be sharing the homework with you very shortly. Just have a look at this video, take some important notes, and complete your homework. All right, see you in the next video. Bye bye.